Hi y'all. Okay, so this is another part of looking about our acids and bases and being able to write chemical equations to figure out what's going on. This is actually going to be a fairly challenging assignment for many of you, and that's totally okay. We're going to practice doing chemical equations next unit because we're almost done with this one. So it's gonna get easier and easier. Kind of think of it as just an introduction, and it's okay if you're still struggling a little bit, and we'll figure it out from there. So I don't want you to stress too much, but I do want to explain how to do this. So I've got 4 practice problems here, and we're just gonna kind of go through them. I'm gonna try and walk you through them, and hopefully it'll make a little bit more sense. But you'll have to let me know. Go ahead and email me, leave a comment. Whatever works for you. So what I've done for each of these problems, and just like your homework, you're given the 2 starting things, right? So in every case, you can find your compounds and you can just write, for this one, I have HI plus NaOH, right? So I know that's what I'm starting with. So you can always start this. We write this plus sign, right? That plus sign just means that they're combining together. That's what we're mixing together. And what we're going to do is we know from this situation that we're going to make a salt. A salt is just an ionic compound, right? So we can make ions off of pretty much any of the elements on the periodic table. Hopefully you remember that group 1 has a positive 1 charge. The second column has a positive 2 charge. If we go all the way over to boron and aluminum, that third column is going to have a plus 3 charge. And then we're going to start adding electrons for the next one. So if you go backwards, if you start at that fluorine column, you're going to have a negative 1 charge. If you go one more over to that oxygen column, it's a negative 2 charge. And with the nitrogen column, it's a negative 3 charge. So if you look at a periodic table or look at your notes, that might help a little bit. That's a real big throwback to the beginning of this year. So we know that we're going to make a salt, which is going to be 2 ions, and we're going to make water. So the first thing that I like to do is figure out where I'm getting my water molecules from, right? Because I know water is H2O, right? So if I'm going to change my pen color to orange, I've got 1H, 2H, 1O, right? So with that information, I should be able to go and write my water, right? H2O plus, and then whatever I'm left with is pretty much my compound. It is important that whichever one is at the beginning stays at the beginning, and whichever one is second stays second. So here I'm going to have H2O plus NaI. That's it. That's all you have to do. So let's see if we can continue to make sense of this as we go through a couple more practice problems. So problem number 2, write a balanced chemical reaction between lithium hydroxide and hydrochlorite, right? So we've got our LiOH plus HClO3, right? So again, I'm going to find those pieces of water because I know water is going to be part of this. There's my H, my O, my other H. It's really important because I see that there's an O over here. Can we use this O, right? That's a great question, but the O for water always comes from the hydroxide. Comes from the OH group, right? So you'll always know to look for that one, right? So from here we have H2O, and then I'm left with this in the beginning, lithium, and then I'm left with this at the end, ClO3. Okay, next one. We've got 2HCl, right? So this is a little different. 2HCl plus CaCO3. You'll notice that here it looks especially different because we've got quite a few things going on. So this is a little more complicated. So right now, this 2 right here tells me that I have 2 hydrogens and 2 chlorines because it's at the very beginning of the equation, right? So another way we could write this, if this mentally helps you think about it, is we have HCl plus HCl plus CaCO3, right? Just like math class, we can spread this out, and that's totally okay if it helps your brain. So we're going to go back, and I'm going to circle where I get these hydrogens from, right? Because I know I want to make water. So I got 2 H's, but I got to find my O. And the only place I can get an O from is over here. And I only want one of them, so I'm only going to take one of them, right? So I'm going to make H2O. This is one of those special ones. So if you remember from the earlier, this is a carbonate. Carbonate. Sorry, that's a really terrible R. Carbonate. Remember that when we have a carbonate, we also make CO2, right? CO2 plus, our last thing is a salt. But let's figure out where that CO2 came from. Let's go with green, right? Here's my C. And then I use one of these, but I have 2 more oxygens, right? That's my CO2, right? So what I should be able to see, going back to this, I have left over, I have 1 chlorine, 2 chlorine, those are both at the end, and I have 1 calcium, right? So remember what I said earlier, if it starts in the front, this one, it's got to stay in the front. If it's in the back, it's got to stay in the back. So we can write this as CaCl2. Right? So a little more complicated. We're going to try another one of these little more complicated ones. We're going to see what we can recognize here. So this one gives us a weak acid. So we haven't practiced with these as much. And then it also gives us a hydrogen carbonate, right? So this is a hydrogen carbonate. Sorry. Right, hydrogen carbonate, right? So it's got a hydrogen and this carbonate compound we just talked about, right? So it's really straightforward. It's right there. We have CH3, COOH plus KHCO3, right? So remember, regardless of what we're doing, we're always going to make water, right? So let's find those compounds for water. In our acid, we actually have hydrogens here, and we have a hydrogen here. This is an organic compound. We're not going to go into what that is, but from these organic compounds, you always take the hydrogen at the very end. It's just a little easier. You're going to take it from there. In addition, this is our base. The potassium has our base, so we're going to take the hydrogen from here and one of the oxygens, right? So we can say that we have H2O. We're going to add, we know we're going to make CO2, right? Because we have a hydrogen carbonate. Remember, if we have a hydrogen carbonate or a carbonate, we always make CO2 plus water and our salt. So let's go figure out where that came from, right? So again, we have our carbon here, and then we have our 2 oxygens, right? That's where that CO2 came from every time. Lastly, I'm actually going to switch to blue. I think the yellow was a little hard to see. We have whatever's up front left, right? And then this, I know this is going to be confusing. This actually has a negative charge, right? So this is a little weird, but this one is going to go at the end because it is a negative charge. So when we write formulas, right? Formulas are written with the positive ion first. Right, so we're going to go write that last part of our formula. So this one is going to start with K because that's our positive one. It's in the first column on our periodic table, so K is positive 1. And then we're going to write our second part, CH3COO. So I know these are a little complicated. It feels really overwhelming. I want you to do your best. Give it a shot. We're going to go into this in the next unit. So I think having a little exposure of it and giving it your best shot, being prepared for questions for the next unit is really going to help your understanding and grow your strength in this. So do your best. I look forward to looking at your worksheets. I can respond to comments on here. You can Schoology message me. You can email me. I try and get back in about 24 hours. Y'all are doing great. I'm so proud of how hard you're working, and please stay safe. All right. Bye, y'all.